throw a fit. I'll do it on YouTube there. So we talked about on page 6, we talked about that if a transversal cuts through parallel lines, then the following, all of these are true. Every single one of these 4 properties is true. Okay? What do you not see here? Vertically opposite, sum of triangle, those you cannot use here. Those are completely like a separate category. They're always true. But these are only true if the transversal you're traveling on cuts through parallel lines. Then you can be guaranteed that these are true. Okay? On the other hand, if it ever asks you this is what this box is referring to. Are lines parallel? Question mark. It's like, hey, show me how you know lines are or are not parallel. That's what I will start asking more often. And so this is going to be what you're going to say. Okay? Show that one of the following is true. Only one. You just focus on finding that one of these is true. And guess what? I'm going to copy paste this. I'm going to copy alternate exterior angles. Show me that they are congruent. Or alternate interior angles. Show me that they are congruent. Because sometimes it's easier, like it could be that one of these is easier to show and requires less work than the other. So you pick which one you want to go for. Okay. And last but not least, CIAs, right? Consecutive interior angles. I just use CIAs to make it faster, but I don't really want to, like, for you to show that it's like, hey, these are CIAs. Like, you actually want to write out consecutive interior angles if possible. So here it is. Okay. So it goes both. It's like the converse of this, right? So you just need to show that one of these is true. Boom, you can say lines are parallel. However, if you see alternate exterior, you're like, yeah, these two are called alternate exterior, and they are not congruent, then you're like, lines are not parallel. So it goes both ways. So let's put this into practice because to be honest, it doesn't take very long to figure it out. Okay. Can I just give you, I'm just going to give you a quick example here. You might have a triangle sometimes, and it's not necessarily symmetrical. And let's say the base is called AB. And then they're going to throw another line in there. And let's say that this segment is called CD. Okay. And you'll be like, triangle, line, whoa, right? What's going on here? And they'll ask you, right? Is CD parallel to AB? Question mark. That's what this is kind of like a scenario that you will encounter. And what's your job? Your job is either show that these two are the same, because what are these two? Corresponding, right? You can show, you can use alternate exterior, whatever the situation is. In my opinion, that one is perfect for corresponding. This one right here. Like to show that this angle and that angle is the same, and then boom, you have parallel lines. Okay, let's put it into practice. Some of them are short and sweet. Some of them require a little bit of massaging, right, to get your answer. So here we go, page 7. And I give you a little hint here on how to do it. Go to 7, and at the very top it says proving if lines are parallel. You can also showing. It's the same thing. Showing or proving their lines are parallel. So this is how I approach it, okay? Try to find an angle pair with a name. That's one of the four. Okay. Notice what it says here. Just gonna put this in brackets. You might have to resort to sum of triangles equal to 180, supplementary angles, vertically opposite angles, straight angles, sum of quads to calculate the angles needed to get a pair. You might have to do some work to around it to start finding numbers. Okay. And then the second step is check to see if the property about them is true. So obviously the first three, they have to be congruent, and the last one you have to see that they're adding up to 180. If yes, lines are parallel. If no, lines are not parallel. So here we go. In each diagram, prove or show whether or not line EF is parallel to GH. Is there more than one way to justify? And the answer is yes. Usually there's more than one way. Okay, so let's look at this. And they're asking if this is parallel to that. There's no symbol anywhere, right? So we're not told that they're parallel. We want to see if that's true. And this is what I will do. So I'm going to grab my highlighter, and I'm going to be like 67, 67. These are what? Corresponding. They're congruent. So in my mind, I'm already saying, yes, these are parallel. Right? Or you can say, right, what are these two called? They're called alternate exterior. So regardless of how you want to go about it, these are parallel. Okay. So this is the transversal I'm traveling on. So you can put a T here, and we're wondering if these lines are parallel. So this is what I will say here. I found a pair called alternate exterior angles. And then the second step, I noticed that they are what? Congruent. So you found a name, you have a name for it, you notice that, hey, that property about them is true, they are congruent. And so therefore, last step is therefore, EF is parallel to GH. Because alternate exterior angles are congruent. That says, so steps 1 and 2, you do not need to show me those. You could technically have just gone to this step and boom, you're done. Okay. I will also highlight this using a different color, or EF is parallel to GH because corresponding angles are congruent. Or, right? And then you're thinking, oh, there's only 2 ways, Mr. Dirksen, that's it. There's more. You're just being annoying right now. So what can I say that? Can I bring the 67 over to here? Look at where my pencil is. The 67 is, this is 67 as well, right? Vertically opposite. If I had the 67 here, these are called alternate interior. They're also congruent. So you know what I'm saying? You just need to show one, but you could technically show all 4 of them, but that's way too much work, right? We're done. Here you were done, right? Let's keep going. So sometimes you have to massage it. Sometimes you just take it as is. Okay, here we go. What about this one? I don't know. Do we have a name for this? Step one, no name. For given angles. Okay, no name for it. Calculate. Dot, dot, dot. Right? So I'm going to use my pen here. You can do it as you, hold on. This is where I see a common mistake. Some students are like, this is 70, so this must be 70. You can't make that assumption because we don't know if these are parallel, okay guys? So what we're going to do is, we're going to bring this over to here. Can we do that? Yes, because these are vertically opposite. So that's always true. You can bank on that. Okay? And so I will say this, no name. Found an angle using vertically opposite angles. I now have a pair called what? CIAs, right? Consecutive interior angles. I now have a pair, okay? And we'll check what they say. This is technically number 2. Let's go 109 plus 70. That is 179. Okay. I noticed that they are not supplementary. And so let's say on a test, you're like, I forgot that word supplementary. You can go ahead and say, I noticed that they do not add up to 180. I'm fine with that. Okay. So the last step is you're going to say EF is not parallel to GH because consecutive interior angles are not equal to 180, are not supplementary. I'm okay with that. Okay. I'm going to say the homework for this is found on page 8, and I think it's scattered somewhere else yet. 1 second. Can't find it right now. Oh, yeah. Page 27, question 1 has the same thing. If you did your homework, sorry, I'm going to put that. If you did your homework, I already assigned 27 and 28. The very first part I asked you to omit. Now you know how to do it. It's asking you show whether or not these lines are parallel. You're doing what we just learned here. So page 8 and page 27, question 1. And I'm going to pretty much every AC that you get from now on is going to have 1 or 2 questions like this, okay? Where I kind of just want you to figure that out. Give me 1 second here. I'm going to see, that's it for today.